All right, so we're gonna go over this first TEK in 7th grade, which is gonna be 7.2a. And basically that's gonna be sets and subsets of numbers. It's a continuation of what they've learned in the beginning of 6th grade, but they're gonna go a little bit further. So the first thing that we have is rational numbers. Rational numbers can be expressed as a over b. So basically, in other words, you can make them into a fraction. So rational numbers are a huge amount of things. It could look like a negative number. It can look like a positive number with a decimal. It can look like a fraction. It can look like a number that repeats and goes on forever. Or it could look like a number that starts and then has different numbers behind the decimal, but as long as it finishes at some point. So what you couldn't have, what would make it an irrational number, or can't be turned into a fraction, would be a number like pi or a number like the square root of 2. What those things do is they would go on forever. So pi would be 3.14, and then it continues on forever, and you don't know what the next number would be. So that would be an example of an irrational number. But a rational number can be a negative number, a positive number with a decimal, fractions, but most importantly, what you need to remember is that it can also be a number that repeats or a number that terminates, which means it finishes. Next, we have integers, which are counting numbers and their opposites. In short, what that means is positive and negative whole numbers. So for instance, we're not going to see decimals with integers, but we will see negatives. So for this example, I use a -3 and -3. And the reason I did that, because I wanted to point out that all integers are rational numbers, but not all rational numbers are integers. Integers are a subset of rational numbers. The next subset that we have is whole numbers. Whole numbers are counting numbers and 0. The way I like to remember this is that, I know it's not the same word, but if you make a hole with your hand, that would make the shape of a 0. So to remember it, whole numbers will include 0. So basically whole numbers, once again, don't have decimals, but they're all the positives. So rational numbers are almost everything. They're positive, negatives, decimals, fractions. Integers are positives and negatives. Whole numbers are starting at 0 though. And next we have natural or counting numbers, the smallest subset. So basically what they do is they start at 1 and go up each time. So it's the same as whole numbers, except we're not including 0. So this is the smallest subset at all of them. So it's starting from the biggest and then goes down to the smallest. So if we want to look at it as a diagram, we can see that rational numbers encompasses all of these other ones. So if you have a natural number, that natural number is also a whole number, and that whole number is also an integer, and that integer is also a rational number. Now separately over here are the irrational numbers. So if you see a chart or something that has irrational numbers on the inside of this, you know that answer choice would be wrong, because irrational numbers and the rational numbers are completely two different sets. So if I were to fill this in with examples, I would know natural numbers are like 1, 2, 3. Whole numbers are going to start at 0. They might have 1. It could be 72. But our whole numbers are going to stay positive. Now when we get down to our integers, we're going to start including our negatives. So -3, let's say 0 again. Let's do -7, and we can also include +11. When we get down to our rational numbers, now we're going to have our decimals. -3.22, +5/6, or we can also just include 3. So once again, rational numbers is including all of these, and the subsets are going to get smaller each time. If I look at the irrational numbers, I wrote a couple examples. We have the square root of 2, the square root of 72, and pi. Now, just because this has a square root doesn't mean it's automatically irrational. And I'll show you why these numbers are irrational. So if I go to my computer and I say square root of 2, you'll see that the number will keep going forever, and you can't predict what the next number will be. It won't stop. The only reason it stopped here is because it ran out of room on the calculator. So now we're going to do the square root of 72, and we'll see the same thing. It's going to keep going, and we're not going to be able to tell what number would come next. Now, on the other hand, if we did the square root of 9, we would just get 3, which is definitely a rational number. So we have to be careful and not make the mistake that just because it has a square root sign, that makes it irrational, because that's not true.